Good morning to all of you. Welcome to my lecture number 6. Myself, I'm Rajan from Department of Agricultural Engineering, working as Assistant Professor at Sri Shanma College of Engineering and Technology. Yes, today this lecture titled Soil Color and Soil Temperature uh, provides an overview of two critical physical properties of soil. Yes, we can go to the topics. First topic is soil color. In continuation of we are looking in soil physical properties. So on behalf of that, today we're going to see that one of the soil physical property, that is soil color. So you might see in different colored soil in different places in nature. In That is might be red or brown or black. The colors are based on the properties of the soil. Yes, you can see in this picture there is different colored soils are as color samples are taken. Yes, this slide introduces the concept of soil color and its significance. So soil color is a key observable property that provides valuable clues about the soil composition, chemical processes, and environmental condition. So the soil color specifically it offers insight into the soil's drainage and organic matter content. Okay, we can move to next slide. There we can see the primary factors determining the soil color. Yes, you can see the different colored soils and their properties and what are the agents making the color to the soil. Yes, the first one is the black dark brown soil. So this soil uh, having the high organic matter, I mean humus content, which signifies the high fertility. So the because of humus is black and coats mineral particles, a high concentration results in darker soil to this type of soil. So the black soils having the high organic under dark brown soils having the high organic under because of that organic content in the soil it having the black color itself. So then next one is the red color soil. So red color soils indicate the presence of ferric iron oxides like a hematite. So that red color soils indicates that a soil has the well drainage and aeration where iron is fully oxidized, often found in the warmer tropical climates. So red soils can be seen in warmer tropical climate zones. The next one is the yellow or yellowish brown colored soil. These colors comes to the soil because of presence of hydrated ferric iron oxides like geotite. Then these colored soils indicates the good and but slightly less complete drainage variation than the red soil. Or these soils are mostly in temperate climate zones. The next one is the gray or blue or green colored soil. So these colors comes to that soils because of presence of reduced iron like ferrous form or iron form of iron. So Fe2 plus ions present in the soils makes that soils to that color. Then it indicates that water logging or poor drainage in the soil. So the lack of oxygen, I mean it in anaerobic condition, causes the iron to be chemically reduced. That process called claying. So that giving it a dull gray or blue or green color to the soil. The final one is the white or pale colored soil happening because of accumulation of salts, carbonates, silica or layer from which colored materials have been leached out. So these white or pale colored soils are common in arid environments or in the acidic soils where organic matter and iron have been removed by bleached from heat horizons. Okay, we can move to next slide. Yes, to measure the soil color of the particular soil, we are using the Monsal system to find the soil color of a particular soil. Yes, these slides explain the standard method soil scientists use to precisely and consistently describe the soil color. The Munsol soil color chart quantifies colors based on the three standardized properties. The properties are hue, value, and chroma. So the hue represents that the actual color of that soil. I going to mark in the marker for your understanding. Or so the hue means the hue represents that actual color of that soil. Then the value represents that lightness or darkness of the actual color. Then the chroma represents that the purity or we can say intensity or saturation of the soil color. So these is the three types of properties and the representation in the soil color. So the notations have been followed like this in for each properties. Here I shown that. So for hue, we have to we can use the in Munchal soil chart the letters and numbers have been used for uh, mention the to show the hue. There, for example, 10 YR. Say here that YR means yellowish red. That is most common soil hue for all type of soil. Then the next one is the vertical scale have been used for mention the values in the Munchal soil color chart. The numbers ranging from 0 to 10 with we are added slash to the slash to right side of that number. So for from 0 slash to 10 slash, if that soil is having the low value like 1 0 or 1 or 2, that means the soil having the soil having the darker color or almost closer to black color. Then final one is the chroma. Chroma is the horizontal scale in the moon soil color chart that is ranging from 0 to 8 plus. That the here the slash is added before the number where the higher number shows that brighter or more vivid colors. Okay, I think you understand. We can see the a problem in the next slide to understand this Munsol soil color chart system, how it working. Yes, here's the notation have to be written in this format. First, we have to mention the hue notation, then value notation along with slash, then chroma notation. So first one we have to hue, then second value, then third is the chroma. This is the format to mention the Munchal soil notation. So for example, 10 YR 4 by 3. Here the 10 YR means the yellow red. Then 4 slash means medium darkness because it almost like uh see if if the number is very less, that gives the that means the darker soil. But the number is almost like it comes to center, the like that is 4. So that's why the soil is the medium darkness soil. Then third one is the number chroma value. That means the moderate color, purity or intensity. So if that value is increased in the chroma, that means that give the high intensity or high uh, purity. But here the number is 3 is less than less. So that's why it has that moderate color, purity, intensity. So understanding this soil color is crucial for agriculture planning and environmental assessment and soil as well as soil classification also. So here you could understand that I think I hope that you understood that how moonshot soil systems uh, used to find the soil color of the particular soil. Okay. So next we can see that another topic. Sorry, we have to see that another important topic in this slide, that is the soil temperature. Yes, soil temperature is important for the plant growth because soil temperature is crucial for physical property defined as the measure of the ground inherent warmth or coldness at a specific depth. So that it is the soil temperature means that it's the ground's inherent warmth or coldness at a specific depth. So it's a major factor in the plant growth and agriculture management and plays a pivotal role in controlling the physical, chemical, and biological processes that occur within the soil. Okay, we can go to next slide. So next slide shows that the importance of soil temperature. Yes, the soil temperature plays a, already I told you that it's a play a pivotal role in the plant growth and agricultural activity because soil temperature is directly linked with the root system of the plant. So this slide outlines how soil temperature influences the matches soil processes. There is the three soil processes occurring in the soil profile that are biological process, chemical process, physical process. The first one is the biological process. In the biological process, seed germination, plant emergence, and root growth and functions and microbial activities are mostly influenced by the soil temperature in adverse way. So first, we can see detailed in each uh, biological process. The first one is the seed germination and plant emergence. So each crop has a specific minimum and optimum soil temperature for its seeds to germinate. For example, maize seeds requires 25 degrees Celsius to grow the root from the seed. So while wheat is around 15 to 27 degrees Celsius needed to uh, seed germination. The temperature, soil temperature should be balanced in the land to grow to help the seed germination. So second one is the root growth and function. So temperature affects root elongation and branching and their ability to absorb water and nutrients. The third one is the microbial activity. So soil organisms presented in the soil organisms like bacteria and fungi that are responsible for the decomposition of organic matter and nutrient cycling. Example, nitrification, one of the nutrient cycling process happening in the soil that are very crucial for nitrogen fixation in the soil that help to plant growth, are highly sensitive to temperature. So warmer soils accelerate these process while very cold and very hot soils warmer soils accelerate these process while very cold or very hot soils slow or halt them. Then the chemical process. In the process, rate of reactions, I mean chemical reactions such as the dissolution of minerals and mineralization increase in the rate as the temperature rises. So the all reactions are rises when the temperature rises. Then second one is the nutrient availability. So temperature affects the solubility and mobility of essential nutrients like phosphorus. So the temperature decides that phosphorus movement in the soil. Then the physical process. So the physical process like water movement. So water movement influences the rate of evaporation from the soil surface that affecting the soil moisture content. The second physical process is the soil structures. So soil structure is majorly affected by the freezing and thawing cycles can help in the creation and breakdown of the soil aggregates influencing the soil structure. Okay, we can move to next slide. So in this slide, we can see the factors influencing the soil temperature detailedly. Yeah, I give the details. What are the factors influencing the soil temperature? You can see that. So the heat dynamics in the soils are governed by the energy exchange primarily with the atmosphere. So several factors dictate how much heat is absorbed, stored, and transferred. First factor is the solar radiation. That is the primary source of the temperature. The angle of incidence influenced by latitude, slope, and time of days or season. So these angle of this incidence determines the intensity of heat absorbed by the soil. The second factor is the soil moisture. So water content we can say. So the wet soils warm up and cool down slowly because of that soil temperature. So water has a high specific heat capacity. It takes lot of energy to change its temperature. Yes, wet soils are also cooled by the large amount of energy required for evaporation. So soil moisture also plays the changes in soil temperature. Then soil color. So dark soils warm faster and light soils stay cooler because of their absorption characteristic. So darker soils have lower albedo. That means albedo means reflectance of the sunlight and absorb more solar radiation. So lighter soils reflect more heat than the darker soils. That's why light soils stay cooler always. Then vegetation or residue cover, I mean mulching activity also plays the changes in the soil temperature. So mulching activity. Mulching is nothing but is the letting the plant in the land after the harvesting to become a manure or a mulch to that land that restricting the uh, water evaporation from the field. So vegetation act as insulation or shading material to soil temperature exchange from the atmosphere to soil. Then plant canopy or organic mulch act as an insulating layer, reduce the amount of solar energy reaching the soil surface. This leads to less fluctuation, I mean cooler in day and summer and warmer at the night and winter season. Then soil texture and structure also playing their role in the soil temperature. So these also are one of the factor that makes the change in soil temperature. So soil texture and structure affects the heat transfer. How the sandy soil generally heat and cool faster than clay soil, and compacted soil conduct the heat better than the loose soil. So the next one is the soil depth. Soil depth due to the soil damping effect happening with respect to soil depth, the temperature fluctuation are greatest at the surface and decrease exponentially with the depth. The temperature deep layer less than greater than 100 centimeter remains relatively constant throughout the year. So that is called damping effect. Okay, we can move to next slide. Measurement of soil temperature. So in this slide, you can see the different measurement tools used to find out the soil temperature. Here, nowadays, there is lot of small devices came to find out the soil temperature easily within a minute or seconds. But okay, but here even though I given the some measurement tools I given to you for reference. The soil temperature is measured to inform decisions on planting, irrigation, soil management. The first measurement tool is the soil thermometer. That is in mercury in glass or digital form uh, can be available in the markets. So soil thermometers are simple, inexpensive tool inserted directly into the soil to specify depth. It's a very compacted tool to find out the soil temperature. Then second one is the thermocouples and thermistors. So these are electronic sensors often connected to data loggers for continuous automated monitoring at various depths. Example 5 centimeter, 10 centimeter, 25 centimeters. We can uh, wires are lay sensors are connected under the ground to find out the soil temperature at the different depths. The third one is the infrared thermometer used to measure surface temperature without contact. So here we are sending the infrared rays to the uh, land, I mean soils. Then it based on the reflectance and reflected data, we analyzing the data. Then we finally going to find the soil temperature through the infrared thermometers. Then the final and the standard depth. So measurements are typically taken at the standard agriculture depth, most commonly 5 centimeter and 10 centimeter. Uh, as these depths are most critical for seed germination and shallow root development. Yes. So I hope that you guys are understood that how soil colors uh, came to the soil. Then how soil temperature affecting this agricultural activity by the plant growth or seed germinations. Yes. Okay, we can to move next slide. Yes, I hope that you guys all have understood the today concepts that are soil color and soil temperature. So in this lecture, we've seen that how soil colors are measured, what is the soil color, how it came to the soils, then due to that properties. Then we seen that soil temperature, how soil temperatures are affected by the different factors and what are the measurement tools are used to soil temperature have been seen in this slide, so seen in this lecture. So thank you for listening. We can see you in the next lecture number 7. Thank you.